Welcome to the first lesson in Session 6 on triangles. A triangle is a three-sided polygon. Triangles are classified by both side length and angle measurements. We're going to start by discussing how triangles are classified by their side lengths. The first type of triangle we're going to discuss is an equilateral triangle, and that's a triangle where all three sides of the triangles are congruent. An equilateral triangle is also equiangular, meaning that all three angles are congruent. So an equilateral triangle has three congruent sides and three congruent angles. And the measure of those three interior angles each equals 60 degrees. Next, we discuss an isosceles triangle. And an isosceles triangle is where it has exactly two sides congruent. And also, since there are two sides congruent, an isosceles triangle also has two congruent interior angles. So the congruent angles will be opposite of the congruent sides. And lastly, we have a scalene triangle, and a scalene triangle has three unequal sides. Scalene triangle has three unequal interior angles. So an equilateral triangle has three congruent sides and three congruent angles. An isosceles triangle has two congruent sides, two congruent angles, and a scalene triangle has three unequal sides, three unequal angles. Next, we're going to classify triangles based on their angle measurement. First, we have an acute triangle, and in an acute triangle, all three angles measure less than 90 degrees. A right triangle is a triangle in which one angle is exactly 90 degrees, and a 90-degree angle is defined as a right angle. The relationship between the three sides of a right triangle is the basis for trigonometry. And third, we have an obtuse triangle, and in an obtuse triangle, one of the angles is going to measure greater than 90 degrees. So we have an acute triangle, all of our angles are less than 90 degrees. A right triangle where one of the angles measures exactly 90 degrees, and an obtuse triangle where one of the angles is greater than 90 degrees. Next, we're going to discuss the properties of triangles. So in a triangle, the sum of the interior angles of a triangle will always add to 180 degrees. So in this triangle that we have here, x plus y plus z, if we add up all three of those angle measurements, it will equal 180 degrees. Next, into exterior angles. The angle between any side of a shape and a line extended from the next side, and in this case, that would be an exterior angle. So the x and the y you see in this case, there's an interior angle and its exterior angle. Anytime you take an interior angle and an exterior angle, they're always going to be supplementary, and they're always going to add to 180. So in any polygon, the sum of an interior and an exterior angle of the same vertex is 180 degrees. Let's see how this looks in practice. So we're going to use the figures of these four questions to answer each one. The figures are not going to be drawn to scale. So in our first one, we need to find out what the measure of angle A is, given that the measure of angle B is 64 degrees and the measure of angle C is 37 degrees. So I know that the interior angles of a triangle are going to add to 180 degrees. So angle A plus angle B plus angle C is equal to 180. And since I have the values of angle B at 64 degrees and the value of angle C at 37 degrees, I can substitute those values into my equation and solve for the missing angle A. That leaves me with 79 degrees. In angle 2, I need to find the measure of angle ACD. Now notice the angle ACD is the exterior angle corresponding to angle ACB, which is equal to 27 degrees. So since we do know that exterior angle and its corresponding interior angle form a linear pair, meaning they're supplementary and add to 180 degrees, I know that angle ACD plus 27 degrees is equal to 180 degrees, leaving me with an angle measurement of 153 for angle ACD. Third, it looks like we have an isosceles triangle. So we're given that set line segment AB is congruent to line segment AC, which also tells me that the two base angles are congruent. So I'm provided with an exterior angle of 108 degrees. So I know its corresponding interior angle is going to be 180 minus 108, which leaves me with 72 degrees. And I know that since angle ACB is equal to 72 degrees, the other base angle, which is ABC, is also going to be equal to 72 degrees. Now I can use the interior angles of a triangle to conclude that angle A is equal to 36 degrees. Last example, we need to solve for x and y. So the system that we're going to come up with here, we're going to have 4x plus 4y equal to 180 degrees. And that is achieved by adding the 3x, the x, and the 4y. Those are the interior angles of the right triangle, of the triangle. They equal 180 degrees. And my second equation is x plus 10y equal to 180 degrees. And that's produced by the interior and the exterior angle. So now to solve this system, we're going to use elimination. So we multiply the second equation by -4. Solving for y gives me a value of 15 degrees. So now that we've isolated y, now we need to find the value of x. Substituting y equals 15 back into my original second equation, I get 10 times 15 is 150, which leaves me with a value of x at 30 degrees. So x was 30 degrees and y is 15 degrees. So that wraps up our lesson. Please feel free to email us if you have any questions, and good luck on the quiz.